AI agents are starting to move past react to the next frame and toward actually inferring the hidden state of the world they're operating in. That matters because in robots, the failure mode usually isn't basic perception, it's mismatched context, camera shifts, morphology changes, stale memory, or tasks that stretch across days. The common thread here is a push towards systems that can reason over interaction history, not just observations. Keep watching, because the real story is how far embodied AI can go once memory, planning, and adaptation stop being separate problems. Let's explore the first paper, In-Context World Modeling for Robotic Control. In-Context World Modeling for Robotic Control from Fudan University and the Shanghai Innovation Institute reframes generalization failure in vision language action systems as test time system identification. Instead of assuming a fixed camera pose or robot morphology, the policy first collects a short self-generated interaction prefix and uses that context to infer the latent configuration before acting. The method, ICWM, reuses a Qwen2.5BL3B backbone with fast action tokenization and requires no parameter updates, task-specific demonstrations, or reward signal at deployment. On Libero, with 8 training viewpoints and 6 unseen OOD viewpoints, ICWM raises average unseen view success from 19.8% with multi-view BC to 25%, and the paper reports especially large gains on Libero long, where OOD success reaches 25% versus 19.8%. In real robot experiments on a 6DOF UR5E with 12 cameras, standard multi-view performance drops from 68% to 17% under viewpoint shift, while ICWM substantially narrows that gap. Ablations show the interaction prefix matters structurally. Removing images causes the largest collapse, and false context performs worse than no context, indicating the model genuinely conditions on inferred world dynamics. The approach also transfers beyond camera shifts, improving under distractor objects, novel table textures, and morphology changes, such as rigid spacers of 20, 40, and 80 millimeters, with a particularly notable recovery at 80 millimeters, where the baseline largely fails. Let's explore the second paper, Vesta, a generalist embodied reasoning model. NVIDIA's Vesta is a unified embodied reasoning model that collapses localization, navigation, embodied question answering, and long horizon action planning into a single Qwen3 VL8B based planner, instead of a brittle multi-model stack. The core technical idea is a curated, supervised, fine-tuning mixture biased towards spatial intelligence, navigation, grounding, embodied reasoning, and real robot data, combined with a minimalist multimodal memory harness that interleaves retained image frames with a running text cache of prior subtasks. Across embodied cognition and localization benchmarks, Vesta reaches 68.7 average cognition and 69.9 average localization, outperforming RenBrain and RoboBrain 2.5 in most categories. On offline real robot planning, it scores 75.4 average versus 38.5 for RoboBrain 258B. On navigation, it matches the specialist intern VLA N1 with 55.5 steradians and 61.4 OS on R, 2R, CE Val, unseen. Most notably, on a bimanual YAM gripper robot with GAR00T N1 6 as the low-level actor, Vesta improved success by 38.3% over actor-only control and 25% over a Qwen3 VL planner, showing that a single generalist planner can outperform specialized systems while remaining directly deployable in hierarchical robotic control. Let's explore the third paper, Worldlines Benchmarking and Modeling Long Horizon Stateful Embodied Agents. Worldlines from HKUST-Z and Noen targets a gap in embodied AI evaluation. Long horizon household assistance, where agents must preserve routines, object locations, device states, and partial observability across days rather than solve isolated short episodes. The benchmark builds evidence-linked samples from Habitat, HSSD household scenes using a project-driven pipeline that generates cross-day traces with dialogue, human activity, robot actions, execution feedback, and state transitions, then converts them into memory QA and embodied task planning tasks. To address the mismatch between flat text memory and stateful embodied reasoning, the paper proposes OBSMEM, which separates event evidence, structured world state trails, belief status, and commitments, and routes each query through typed retrieval plus evidence selection. On 310 memory QA samples, OBSMEM reaches a judge score of 0.713 and perfect rate of 69%, outperforming AI MEM at 0.575 and 53%, and improving event R at 5 to 0.537 versus 0.378 for MEM 0. On the hardest state MHE setting, it climbs to 0.452 versus 0.264 for MEM 0. In a 2-1 sample planning probe, OBSMEM also leads with a plan judge of 0.684, showing that observer-grounded memory transfers better into executable household plans than MEM 0, memory OS, or graph-based memory. That's a wrap on today's AI paper highlights. Thanks for watching.